Welcome to Chronicles of Humanity Stories.
The formation of Earth and of humankind.
Earth is a dynamic planet in constant flux, and despite all the progress we've made in understanding its history, its story is still being written. But while no one can predict what the next chapter might bring by piecing together clues from deep time, scientists have been able to reconstruct our planet's history over billions of years. So here's the story of Earth, starting from its fiery origins and following key events that shaped the world we know today. 4.6 billion years ago, Earth was just an idea. A solar gas cloud so massive it was thousands of light years wide collapsed in on itself. Gravity pulled the material into a rotating disk around an emerging baby sun. In this swirling disk, dust particles collided and stuck together, growing larger and larger until they became planetesimals. Over millions of years, these planetesimals grew to become the Earth, which was big enough to start pulling in surrounding gas and rock, building up its atmosphere and oceans. About 100 million years later, Earth was born, at least according to the most widely accepted theory for how our solar system formed. But how old is Earth exactly? Scientists determine the age of rocks and minerals by analyzing isotopes of elements found within them. For example, uranium decays to lead at a constant rate. So, if a meteorite or ancient rock contains mostly uranium but very little lead, then it's relatively young. If it has mostly lead, then it's much older. Isotope dating of meteorites, along with analysis of ancient rocks known as zircons, suggests that Earth formed around 4.54 billion years ago. At first, Earth's surface was hot, molten rock, but as it cooled, heavy elements like iron sank to the core, while lighter materials formed Earth's first crust. Then something huge happened. When Earth was about the size it is today, it got hit by a Mars-sized body called Theia. This giant impact sent debris flying into orbit. Some of this debris eventually formed the Moon. Without the Moon, Earth's days would be just hours long instead of 24. With our giant satellite, Earth also has unusually high tides and a more stable rotation axis. As a result, Earth's seasons aren't too extreme. In the aftermath of the giant impact, Earth continued to cool and its surface solidified. Around 4.4 billion years ago, ancient zircons indicate that there was already some continental crust. Solid rock exposed above sea level, hinting that Earth's surface was changing quickly during this period. But not everyone agrees that the giant impact was a one-time event. Proponents of a giant impact, followed by several smaller impacts, propose that the late Vernier model explains the Moon's unusual nitrogen-rich composition and why it has so few aluminum and phosphorus atoms. As Earth cooled, water vapor condensing in the atmosphere formed oceans, which interacted with the crust and atmosphere. Gradually, plate tectonics began operating. Ocean water mixed with melted rock from the mantle, recycling minerals from the crust into the air and back onto the surface. At the same time, volcanic outgassing released gases from the interior to the surface, where they formed the first atmosphere. Earth's early atmosphere was probably rich in carbon dioxide and nitrogen, with little free oxygen. Life first emerged at around 3.5 billion years ago, leaving behind ancient bacteria and fossils of layered structures called stromatolites that were built by photosynthetic cyanobacteria. Eventually, photosynthetic organisms started producing oxygen as a byproduct. At first, the oxygen reacted with iron to form rust, giving the ocean a reddish color. Banded iron formations are rock layers that contain alternating bands of iron-rich minerals and chert that formed when the oxygen in the ocean caused the precipitation of iron hydroxide. Iron levels dropped significantly when Earth's surface oxidized, marking the Great Oxidation event. After the rise of oxygen, Earth experienced a second atmosphere. The oxygen accumulated in the atmosphere, creating a layer of ozone, or O3, which absorbed harmful ultraviolet radiation from the sun, allowing life to thrive and diversify near the surface. The ozone layer still protects Earth today. Around 2.7 billion years ago, Earth had its first eukaryotic cells with complex internal structures bound by membranes. One prevailing hypothesis, known as the endosymbiosis theory, proposes that eukaryotes arose when smaller prokaryotic cells entered into a symbiotic relationship, with one cell living inside the other. Mitochondria likely formed first, followed by chloroplasts in photosynthetic eukaryotes, which may have originated from ancient cyanobacteria. As life diversified, continents assembled and broke apart. Mountains rose and eroded away. Oceans evaporated and new ones formed. Multicellular organisms developed around 1 billion years ago, kicked off by the evolution of simple colonies of single-celled eukaryotes. But during the Cryogenian period, most of Earth's surface froze over in a snowball Earth event. Then the Ediacaran biota appeared, named for the famous site in Australia's Flinders Ranges. It includes some of the earliest large and complex multicellular organisms, such as jellyfish-like animals and the first ancestors of modern corals. Many of these organisms were wiped out during the subsequent Cambrian explosion, starting around 541 million years ago. The Cambrian explosion refers to a dramatic increase in the diversity and complexity of life on Earth, marked by the appearance of nearly all major animal phyla, including the phylum Chordata, which includes us humans, as well as vertebrates or animals with backbones. So much happened during the Cambrian. All major animal groups, except for bryozoans, brachiopods, mollusks, and annelid worms, appeared during this time. Trilobites dominated the seas, and strange creatures like a Nomolocaris swam around. As animals evolved, plants took their first steps onto land around 470 million years ago. Early plants spread across the continents and altered the environment through photosynthesis and by weathering rock. By 400 million years ago, forests appeared. They consisted of early vascular plants like lycopods, ferns, and the ancestors of modern horsetails. Meanwhile, Insects flourished. Lobe-finned fish were the predecessors to four-footed vertebrates. Around 365 million years ago, some lobe-finned fishes developed fleshy limbs with digits, adapting to life on land. These tetrapods included the ancestors of amphibians. As amphibians were evolving, early amniotes were also developing. Amniotes are a group of tetrapods that possess an amnion, a membrane that encloses a fluid-filled sac protecting the embryo. Amniotes could live far from water because their eggs could survive on land. The first amniotes laid eggs with shells. Later, the group split into two lineages. One gave rise to the reptiles, including dinosaurs, which eventually went extinct. The other led to the ancestors of birds and mammals. Birds descended from one group of theropod dinosaurs, small, feathered carnivores. Dinosaurs dominated Earth for over 165 million years until a cataclysmic event 66 million years ago changed everything. The Chicxulub asteroid, measuring about 7 miles across, crashed into Earth. Its impact triggered earthquakes, tsunamis, and climate change, initiating the Cretaceous-Paleogene mass extinction, which wiped out roughly 75% of all plant and animal species, including the dinosaurs. Only birds survived among the dinosaurs. Small mammals, which had been overshadowed by dinosaurs, were now free to diversify. The Cenozoic era, or Age of Mammals, began. Rainforests expanded, fruits and flowers diversified. Primates evolved, homins appeared, eventually leading to Homo sapiens, who spread across the globe, becoming the dominant intelligent species on the planet. 7 million years ago, the hominin branch diverged from the common ancestor shared with chimpanzees. Australopithecus afarensis walked upright consistently, as evidenced by the famous fossil Lucy. Around 2.4 to 1.4 million years ago, Homo habilis made and used Oldowan stone tools. Homo erectus lived 1.9 million to 140,000 years ago. He had a highway body adapted for running. Homo erectus migrated across Asia and Europe, was the first hominin species to use and control fire. Anatomically modern Homo sapiens first appeared in Africa is greater than or equal to 300,000 years ago, moving out of Africa in waves, beginning around 70,000 years ago. Interbred with Neanderthals outside of Africa and with Denisovans in Melanesia and Southeast Asia. Today, humans outside of Africa carry about 1 to 2%. Neanderthal DNA and people in Oceania have an additional 4 to 6% of Denisovan ancestry. Humans reached Europe and East Asia around 45,000 years ago, and the Americas around 15,000 years ago, perhaps via ice sheets or coastal migration. Around 12,000 years ago, agriculture developed independently in Mesopotamia, China, and the New World, sparking population growth and the domestication of plants and animals. Around 6,500 years ago, the first cities and states appeared. Then, around 5.3 thousand years ago, writing was invented in Mesopotamia, marking the beginning of recorded history. Since the advent of civilization, humans have greatly expanded their influence on Earth's systems and now face major global challenges. Humanity will need to continue piecing together the story of Earth to find solutions to the problems we've created. Understanding how our planet came to be and how life has evolved on it gives us insight into the processes that shape our world and ourselves. From the solar cloud that coalesced 4.6 billion years ago to the emergence of Homo sapiens, Earth has undergone countless changes. Each of these changes has brought it closer to the form we know today, and each of these changes also brought life closer to the forms we know today. Every creature on Earth, including us, is part of an unbroken chain of life stretching back billions of years. As long as life continues to evolve, Earth will continue to change, continuing its story into the future. If you enjoyed learning about all the amazing things that happened on Earth throughout history, then you should check out our videos on space exploration. You can watch a video about how scientists search for life on exoplanets, or another one about NASA's plans to send humans to Mars.
The history of the formation of the Earth and the origins of humans ends here. In the next part, I will tell you the story of humanity and the first civilization in the world. If you find the content meaningful, please don't hesitate to give me a like and subscribe to stay updated with the latest historical stories from this beautiful planet.